Hello and welcome to Database Management Systems. I'm Chivita Christie, and in this video, I'm going to explain to you different types of hashing uh, functions as well as different types of collision resolution and rehashing techniques. So let's begin. First, we are going to study what are the different types of hash functions. So first, we are going to study different types of hash functions. We can create a hash function by a division method or by folding method or the Midsquare method. Let's take a look at the division method. So the division method works something like this. If you have a key like 53 and you want to insert it into a hash table of size 10, then you're going to do 53 modulo 10, which gives you the remainder instead of the quotient. So the remainder is 3. And that's why 53 will be stored in the bucket with an index 3 in the hash table. So it's a very simple method called division method. And this is in most of my examples, I'm going to be using this because of its simplicity, although it's not very practical. But because it's so simple, it is very much preferred while explaining hash tables. The second method is called the folding method. So in this, if you have a key like 5, 6, 7, 8, then what you're going to do is you will divide it into different parts. For example, you are dividing 56 and 78. So because it's a 4-digit key, I can choose to divide it into 2 parts of 56 and 78. If you have 5 digits, you could choose to divide it into 2 parts where one contains 2 digits and second one 3 digits, or first one is 3 digits, second is 2 digits. That's entirely up to you. And once you have divided it, but obviously you have to keep it uniform. If you have several keys coming to you, you have to keep the dividing of the parts uniform. You cannot just go about dividing any way you like. If you have decided to keep in the first part more digits than in the second part, then that has to be followed throughout the course of creating the hash table. Now, once these parts are ready, you're going to add the 2 parts. So we're going to add 56 and 78, which gives us 134. And 134 is the place where the bucket index where you will store the key 5, 6, 7, 8. And of course, in this case, we are talking about a really large hash table which has more than 10 keys. Which has more than 10 buckets. So the size of the hash table is always much larger than what we are going to use in our examples. The third type of hash function is known as the Midsquare method. Now the Midsquare method is something like this. If you have a key 1, 2, 3, 4, then you are going to first of all square it. So we take the square of 1, 2, 3, 4, which gives me this number, which is a really large number. And once I get this number, what I'm going to do is take the middle portion of it. So for example, in this case, I am taking 27. So once again, the number I got was 1522756, and I am choosing to remove the first 3 digits and the last 2 digits because maybe my hash table contains only buckets up to 100. So I want my key, my bucket number to be a 2-digit number. So in that case, I have to secure a 2-digit number from this squared number. And obviously here the question would be what happens if there are in this case because there are 7 digits, I think. So yes, 4, 5, 6, 7, 7 digits are there. So because there are 7 digits, I have to remove the first 3 and the last 2 and pick 27. But it's possible that there are 8 digits. Then I can evenly remove first 3 and last 3. So if I'm choosing that when I have odd number of digits, then I'm removing more number of digits from the left-hand side. Then I have to keep it uniform throughout the formation of the hash table. So doing that, I have picked 27, which means my key, which was 1234, will get stored in the bucket number 27. That is the mid-squared method. And this is only a gist of all the methods, but there are several other methods in hash functions because there's always lots of research being done on this. So I've only explained the 3 very basic and easy to understand ones, but there are many others available. Now we are going to see a problem that can happen in a hash table, which is called collisions. So let's take a hash table of size 10. And now I'm going to use for all these purposes the division method because that's the easiest one. And because the size is 10, I just have to worry about the last digit of my key. So 33 is the key that I want to store, which means I'm going to do 33 modulo 10, which gives me 3. And so 33 will get stored in the bucket 3. Let's say that next I want to store 73. And when I do 73 modulo 10, it once again gives me 3. So when I try to store 73 with 33, it creates a collision. Since I cannot store the bucket with the same key in the since I cannot store more than one key in the same bucket. So this is known as a collision. And no matter how good your hash function is, you will always have collisions at some point or the other because your hash table is also going to get filled slowly. And that's why the more number of keys, as the keys increase and the hash table starts becoming fuller and fuller, you will find out that there will be more collisions occurring. And there are ways to handle these collisions, which we are going to see now. And these are called collision resolution techniques. The first such technique is a simple chaining method. In this technique, if you have a key, for example, 33, and let's just do modulo 10 and store 33 in position 3. Then I have a key 73, and so I'm going to do 73 modulo 10 and store it next to 33 by forming a linked list in that position. So 33 will store the address of 73. It will point to 73 instead of creating a collision. So let's say that next I have another key, 47. So I can do 47 modulo 10, which gives me 7. So 47 will get stored in position 7. And if I have 43, I can do 43 modulo 10, which gives me 3. And so because it's a collision again, I can create a longer chain in bucket 3 and store 43 over there. The next method to avoid collisions or to resolve collisions cannot be avoided is known as linear probing. So let's try to insert these keys. And this time I'm not going to do the calculation of modulo because it's understood by now that when we do modulo 10, all we get is the last digit of the number. So I'm just going to insert all these keys and show you what linear probing is. So let's insert 3. 3 will, of course, get inserted in third position. 7 gets inserted right here. 6 will get inserted right here. 9 gets inserted down there. 31 in position 1. 19, now there's a collision. So what we do is we try to insert 19 in the next free bucket, which means because we are at the end of the table, we have to start looking from the top. And from the top, the next free bucket is at 0th position. So 19 gets inserted there. Then 95 gets inserted in 5th position. And 54 gets inserted in 4th position. Now for 64, there's a collision. So we move to the next free bucket. The next free bucket after 4 is 8. So it gets inserted at 8th position. 43 has a collision. So if we go for the next free bucket, then we are going to reach the end of the table and start again from the top when we will find 2. So 43 will get inserted at position 2. Now there are 2 keys left, 47 and 10. Now I have no way of inserting these 2 because I'm doing linear probing. And you would say that that means chaining might be better, but chaining could cause a problem because the whole purpose of a hash table is to get you data as quickly as possible. And that's why we are creating a hash table and taking so much trouble to do it. But if you did chaining up to such an extent that there's a really long chain, then the hash table no longer gives you data very quickly because then it has to go through that entire chain of numbers in order to find the data that you need. So that's why chaining has its own problems, and linear probing will make your table eventually filled. So what do you do then? Then we do something called rehashing. In rehashing, we try to increase, and by increase I mean double the size of the table. Rehashing is essentially done when your table is, when your table is half filled, or you find out that there are lots of collisions happening and you would like to get a bigger hash table. So in both the cases, rehashing is done. Now, if your table is only filled by half, then you can just double its size in order to avoid collisions because that's when the collisions are going to start to happen. But what happens to all the keys that you inserted? These were all the keys that I had inserted in my previous table of size 10. Now I have a table of size 20. I cannot keep these keys in the same positions now because the size of my table is different. So I have to do the hashing function, to apply hashing function to each and every key again. That is why it is known as rehashing. So we are going to do rehashing. This time we cannot use modulo 10, we have to use modulo 20 as that's the size of the table. So when we do modulo 20, 3 gets inserted in position 3 as usual. Then 7 gets inserted in the 7th position. 31 gets inserted in 11th position. And 19 gets inserted in the 19th position. And we have 64, which gets inserted in the 4th position. We also have, let me show you that. Yes. So we also have 43, which is going to get inserted in 3rd position. But since it is already occupied, we can now use linear probing or any other technique that you want. So maybe if we use linear probing, we can put 43 in position 5 because that's the next free bucket. 6 gets inserted in 6th position, 9 in 9, 95 in 15th position, and 54 in 14th position. These are all remainders when you divide these numbers by 20. So 47 cannot be stored in 7th position. That's why we are going to move to the next empty space, which is here. And finally, 10 gets stored in 10th position. So this is how you can do rehashing. Now there were less number of collisions because I did rehashing. And once again, you can see my table is almost half filled. So this would be a time when you would be doing another rehashing where you will make your table size 40 now instead of 20. So this is how hash tables work in practice. And I've shown this to you with very simple examples with a very simple hash function too. In reality, there would be a very complex hash function in order to avoid lots of collisions from happening. So that's it for this video. I'll see you in the next one. Thank you for watching.